And we are back, and welcome to the Daily Space Weather. Congratulations on realizing the channel exists. Let's blast through a bunch of fascinating data. Starting out with the 171 angstroms wavelength here from the Solar Dynamics Observatory. Multiple sunspots in the southern hemisphere, none in the north. Relatively low levels of activity here. Sunspots have been underperforming. Because we didn't show up with a video yesterday, we put up 2 days worth of colorized magnetogram today to show you the evolution of the plage there up in the northeast. That's up here, by the way, for you new viewers out there. And the sunspots in the south have largely remained stable over the past 24 hours. The best view to look at solar flares may be 131 or maybe this wavelength, 94 angstroms. More about solar flares a bit later in the video. Radio flux only at 102. 10.7 centimeter radio flux for you new viewers. And non-experts in heliophysics, the radio flux is the most proportional data set we have to sunspot number discovered in 1947. This black line here is the radio flux. And you can see how proportional it is to the sunspot number, which is the red line below it. Space Weather Enthusiast dashboard not forecasting any space weather storms. I would concur. There are no CMEs headed Earth's way. They've all either missed or struck, and largely with glancing blows. Next, earthquakes over the past 24. We see a swarm here north of New Zealand. Otherwise, pretty calm levels of earthquake activity. Not that much going on. That 4.6 at the Fiji Islands was over 602 kilometers estimated depth. Looks like the largest of the past 24 may have been this 5.5 at Greece. Indonesia saw a 5.3. Kermadec Islands, that's another area north of New Zealand there. A 5.0 there at the Kermadec Islands. Indonesia saw a 5.6. Oh, there we go. There's the largest quake of the past 24. It's this 5.7 at the Kermadec Islands. Remember, folks, any earthquake can be a foreshock. Please be prepared if you're in an earthquake-prone zone to be an asset, not a liability, in the event of a disaster. That is definitely the most active region there, that area north of New Zealand around the Kermadec and Tongan Trench area. There's a trench that goes right from New Zealand to Tonga. Argentina saw a 5.5. So that's where the majority of the activity is happening, down here in Oceania. Next, volcanoes. I'm interested in what's erupting. And so we cover it daily. Shivaluch exploding. 14,000-foot ash plume from Shivaluch on the Kamchatka Peninsula. Subinosejima in the Ryukyu Islands exploding. 6,000-foot ash plume from Subinosejima. Fuego exploding. 16,000-foot ash plume from Fuego. That's located in Guatemala. Nevado del Ruiz producing a 19,000-foot ash plume over Colombia as it explodes. It's a flight level 190. Sangay exploding, flight level 200 over Ecuador from Sangay. Flight level 150 or a 15,000-foot ash plume from Revenador. That's also located in the country of Ecuador. Sabancaya were unable to detect whether or not it's erupting. Please don't pole vault the caldera. Please do visit the links below the video. Support the channel. Check out smashamash.com. Welcome to the Dale Renaissance. Check out our merch. Become a member of the Smash team if you'd like to support the content. We replace Patreon with something vastly superior. If you're one of our patrons, cancel your Patreon membership and become a Smash team member. We didn't produce a video yesterday. It's a rare thing. We've missed maybe one video in the past couple of years. And of course, exclusive content there for Gold and Silver and Gold Annual Paid Up subscription members. Next, looking at magnetic data here, we're seeing fairly smooth curves here as a coronal hole wind stream subsides. We'll get to that data in a minute. First, the composition of the heliospheric current sheet in terms of the plasma polarity. Yeah, what you're looking at there is plasma polarity, folks. The plasma that comes out of the sun is oriented to one pole or the other. As you can see here, most of it's oriented to the southern pole, shown here in red. That's a south pole current sheet. On the opposite side of the sun, we've got a north pole current sheet. No changes expected to come to that anytime soon. Keep in mind the magnetic environment can change with no warning. Here's a line of sight view showing the colorized magnetogram, the regular magnetogram also. Not the colorized magnetogram. Again, all the sunspots are in the southern hemisphere. The south pole-oriented coronal hole here in the east has gone trans-equatorial. It's just reaching up to the equator or so. That line of sight coronal hole plot also showing you the sun's B field in blue. As solar cycle 25 progresses, we're seeing a shortage of coronal holes and underperforming sunspots. So less coronal holes, does that correlate with less solar flares? Let us know in the comments what you think. And here's a visual analysis in part of the ultraviolet spectrum, 193 angstroms from the SDO. Pretty well-defined coronal hole over here. That is South Pole oriented, reaching up toward the equator, perhaps not across it. Next, we'll look at sunspots. Again, most of them they're all in the southern hemisphere. There was a moment up here where there was some umbra apparently detected, but we've got at least 3 named groups in the southern hemisphere. Here's a close-up of the southern hemisphere. Great imagery there, and you can see how they've remained largely stable over the past 24 hours. Likelihood of large solar flares is still there. Sunspot 2927 showing up at least with some signal here of a beta-gamma class classification. 2924 and 2927 are the most likely spots to see solar flares. That's your flare monitor and your detected sunspot groups with magnetogram. As you can see, these large sunspots have been underperforming in terms of their X-ray output. There's the last 3 days. No spikes in the proton flux, although we just did see a coronal mass ejection. We'll cover that in a moment. First, the real-time solar wind. So we did see another minor CME strike right here, just a little glancing blow there. And you can see multiple signals showing up here at the same time, including a change in the phi angle, a change in the density and the speed and the plasma temperature. That's a tiny little glancing blow, barely even a tick there. A minor strike on the geospace. Again, the coronal hole high-speed stream has been subsiding here over the past 24 hours. Current conditions are solar wind speed of about 440 kilometers per second, solar wind density quite diffuse here at around 4 protons per cubic centimeter. This is the subsiding of the coronal hole wind stream as well. We did reach geomagnetic storm conditions for 4 to 6 hours there. Late in the day on the 9th, since then, geomagnetic calm conditions. And let us know if you've got any images of aurorae. You can hit us up on Twitter or Getter or on the Smash team, for example. Next 4 hours of our geospace magnetosphere movie here, showing magnetohydrodynamic pressure around Earth's magnetic moment from space. The sun would be off to your left in this imagery. You're looking at the equatorial plane and meridional plane as if the Earth's geospace has been tilted 90 degrees here for the Space Weather Modeling Framework model. Again, it's showing you magnetohydrodynamic pressure. The units are nanopascals. It's 4 hours of data. Pretty homogeneous pressure here over the past 4 hours. Nothing too remarkable happening there. How about ground magnetic perturbations? Earth's own B field being measured in magnetic flux density from the ground level. More like being modeled from the ground level. And you're going to see more equatorial type pulses here when you see non-geomagnetic storm conditions, as you can see there from around Southeast Asia, the West Pacific, some minor magnetic pulses there. Again, nothing very remarkable happening in the past 4 hours. And we're moving into a gibbous waxing moon here. Here's the next 7 days of what will be going on in the solar system as Venus swings past. We should have some fantastic imagery of Venus from the weekend as it reached its inferior conjunction, where it passed right between Earth and Sun. There's where things will be in a week. It looks like that's full moon day on the 17th. And here's a star chart if you're wondering what's going on above my head. I would note here that the moon is pretty close to the sun, but not that far off of the ecliptic. Oh, that's Venus. Never mind. Anyway, if you're up before dawn, you might see Mars rising ahead of the sun. And of course, the moon is rising later and later at night here. For those of you in the Western Hemisphere, you may realize that we see full moons around midnight time, when the moon happens to be around its apex of its flight across the ecliptic, which is this yellow line that we've drawn in here on our star chart. And let's take a look at the coronal mass ejections that have recently occurred and are actually happening now. The view from stereo A here at Lagrange 5 and the LASCO SOHO C3 at Lagrange 0.1. That's on your right. Stereo A coronagraph here on your left. From the perspective of stereo A, the Earth would be off in this direction, and from the perspective of the LASCO C3, the Earth would be behind you. And there you can see Venus on the LASCO C3. Coronal mass ejection watch on the Earth side of the Sun. So we forecast coronal mass ejections on this side of the Sun, not this side. Coronal mass ejection watch. If it changes to a warning, we'll probably make another video about it. Check our cosmology segments if you haven't before. Our playlists, we've got various playlists here at youtube.com/smashamash/playlists. So check those out. Thanks to everybody who's done so. No cosmology segment today. Next, we're going to look at charging hazards. Yes, charging hazards. No charging hazards at the moment. We see low levels of electron flux. Here is the 1-year chart from Solon.info. Here's the 3-day chart, and you can see the electron flux cratered as we forecasted 2 days ago. No surprise to our regular viewers. It's associated with the onset of a coronal hole high-speed wind stream. And basically right where I placed the forecast here a couple of days ago. Yeah, it's an electron forecast. Next, the total electron content forecast, showing you the electrons in the plasmasphere and the lower Van Allen belt, the area in between your GPS satellite and your handset, the total electron content forecast, showing you the most likely spots for GPS errors. When GPSs must communicate through a lot of electrons, the signal gets refracted, creating errors. And that's what we're seeing here. We can expect these to subside a bit here with the subsiding of the coronal hole wind stream. I'm going to let it play through a second time. We do see some anomalies here over North America and the Southern Ocean and the Southern Indian Ocean and a bit over the Atlantic. Anyway, that's a total electron content forecast. Next, we'll show the ionosphere layer. The F layer is located at about 300 kilometers of altitude. Here is the ionogram for the past day. It's showing vibrational frequency in megahertz. Millions of vibrations per second. There's a lot of vibration going on above your head. And if you're frightened of CERN, I suggest you take Physics 2. Next, your anomalygram. That was the ionogram. Here's the anomalygram, and we're seeing lots of low-frequency anomalies here. Places like Southern Africa, the South Atlantic Ocean, around the Drake Passage. Low-frequency anomalies showing up there in red. This graph shows you the anomaly in megahertz from the 30-day median. Continued low-frequency anomalies here around the Drake Passage. Some high-frequency anomalies around Central Africa as well. Let's bring up the latest image. That's 12:45 Universal Time. There's the ionogram, and there is the anomalygram. And let's do bonus features. And bonus feature number 1 is pretty up-to-date here. Cerro Tololo. Cerro Tololo, Chile's ground-based solar observatory. Less than 3 minutes. Less than 3 minutes old is the latest data here. It looks like there may be some flaring actually happening here from sunspot 2924. One of the largest sunspots of the whole cycle. And let's see what's showing up here on the NASA GO 16 SUVI. You can see this prominence happening down here. And we may have to make another video later about that. It does not appear to have ejected in the earthly zone. I think that's part of the far side coronal mass ejection we covered earlier in the video. Next, your latest intensitygram and latest colorized magnetogram. Sunspot 2924 is getting its ombre very far apart here. Some additional trailing ombre there. There's 2926. And this one over here is 2927 at a completely different latitude. And all the sunspots once again in the southern hemisphere, which has sort of been the pattern so far in cycle 25. Heavily weighted to the South Pole in terms of solar activity. Become a member of the SMASH team if you enjoy the content and you'd like it to continue to be publicly visible and free for all to view. smashamash.com/SMASH team. Links below the video and on the homepage at smashamash.com. Thanks for tuning in. Congratulations on realizing the channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of SMASH News Network, least busted name in news.